Hey, welcome back, and in this video we are going to get started with the programming language Rust. Now of course we're going to download Rust onto our machine, get it installed, and then download the VSCode extensions and write our first Hello World application. But before we do that, I'm going to tell you why Rust is important, especially in the JavaScript and WebAssembly ecosystem. So first things first, Rust isn't a new language. It's been around for a while. In fact, I think they started development of Rust back in maybe 2006, and it was one of these sort of personal projects that was being run out of the Mozilla Foundation. Now in the last few months there's been a lot of change with all the Mozilla layoffs and all that, and actually Rust has came out of Mozilla, and there's now a brand new foundation sort of formed which is governing the language. But I think the key thing is that over the last few years Rust has gained a lot of popularity in the language, and I think the main reason it's gained that popularity is because actually it sort of acts as this really great integration language, and I'll explain what I mean by that in a second. So Rust is a high-level language. It's like C or C++ or even Go. It's a static language, so it's not like JavaScript or Python, which are dynamic languages, and therefore the code that you write is interpreted by the runtime. The code that you create is compiled into static files when you write the code. Now, why is that important? Because it gives you performance. So you can write much faster, more performant code in something like Rust than you could in JavaScript. It's not an either or. I don't need to go all in on JavaScript or all in on Rust. What I can do is then start interroping between the two when it makes sense. So I can start to write my code in JavaScript if I want, and then if I need something performant, I can write that piece in Rust, and then I can interrupt the two together. And the way you would do that is essentially by exposing your code as modules in the same way as you would in JavaScript with ES6 modules. So that becomes really important. It's a really nice way of integrating, and you can sort of mix and match between the two. So the second part to that is actually some of the things I can do with Rust is if I need to interface with other bits of code, maybe it's like an AI module, something like Hugging Face or something like that, actually I can start to write some of that code in Rust and then expose it back into JavaScript if we want. And I'll do a video at some point showing how to do that. So it makes it really easy to start to get into this hybrid world of where I start mixing, matching my code and sort of pulling in modules where I need. The second use case that I think is really important in the space of integration is going to be WebAssembly. And I've covered WebAssembly in my other videos, and I've shown you how to hand code WebAssembly files. Now, in reality, in a kind of professional coding environment, you're not going to hand code WebAssembly, but what you would do is use a high-level language to create your WebAssembly, and you would compile down into WebAssembly. And that's what Rust is, right? Rust is a really great language, probably the best language for coding WebAssembly, and it's pretty easy to target out the code to run as a native Rust library or as a WebAssembly library, and then you can start to mix and match. And again, in some of my other videos, what we're going to do is take the output of some of our Rust code and then show how you can integrate that in the browser or on the back end as WebAssembly files and compare what the hand-coded version is versus the Rust-generated version. Anyway, with all that being said, I think you get why Rust is super important. And of course, it's important as its own language, right? You can just create everything natively in Rust and you can get a great experience. But I think these hybrid scenarios are probably the key use cases over the next few years. So with that being said, we are going to get started and we're going to start coding up some Rust. And the first thing we're doing is we're going to get it installed. Alrighty, so the first thing we need to do is obviously download Rust onto our machine. So actually, if you just type something like Rust language on your browser, and then you're going to see the www.rustlang.org appear. So if you just click on that and then click on the install tab at the top there, it's going to give you a really nice way of installing it. So it just detects what sort of machine you're on, whether you're on macOS or Linux, etc. And then it's going to tell you how to download that. So you see it's given us a nice little command for curling and installing Rust. So I'm just going to copy that, and then I'm going to open up my terminal. And then let's just put that in the background, and then I'm just going to paste that in there. So all you can see it's happening is going to download the Rust installation, and then it's going to execute it on the shell. So if I just run that for a second, it's going to start downloading that installer. It gives me a couple of options there. So I can either proceed with the installation, default, customizer, or cancel. So I'm just going to proceed with that. Key thing there is if you want to uninstall Rust at any point, you can type in rust up self uninstall at the end, and then it goes. So that's something just to be aware of. So I'm just going to hit return, and then that's going to install that. It'll take a few seconds. Okay, now that it's downloaded and it's installed, all I need to do is restart my shell so that it's got all the path stuff installed. Now that I've opened my new shell, if I just want to check that Rust is working okay, I can just type in rustc ---- version, and it will tell me the version of Rust that I've currently got installed. So you can see that rustc, and I'm running version 1.55. So I know that Rust is installed on my machine and everything is good. By the way, if you already have Rust installed and you want to install the latest version, you can use the Rust Up tool, which is also installed on your machine, and then you can just type update, and then it will check what the latest version is, and then take the latest version, download it, and install it for you. So you can see in our case, just because I've already installed it, it's not going to do anything interesting because it's updated. And as I said before, if I wanted to uninstall it, I could do rust up self uninstall, and then it would remove Rust completely from my machine. I'm not going to do that because then I'm going to have to reinstall it again, which is going to be a pain. So, but that command is available for you if you want to do that. Alrighty, so what we're going to do now is we're going to create our first Rust application. So I'm just going to create a new folder. I'm going to call this Rust Play 2, just so I know where everything is. We'll cd into that, and as you see, it's an empty folder. So to create a brand new application, Rust is got a package manager called Cargo. So it's very, very similar to NPM, and in fact, when they created Cargo, they used NPM as the reference for how to create package management. So it's heavily influenced. So if you're a JavaScript developer and you know NPM, Cargo is going to feel really familiar to you. So like NPM, where you would create a new project by doing an NPM init, you can do the same thing with Cargo. So I can just type in Cargo new, and I'll create a new folder. Let's call it Chris Math. So we're going to create a little math library, which will sort of add some numbers together. So if I just do that, do Cargo new Chris Math, you can see if I just ls there, it's created this folder called Chris Math within that folder. So if I cd into Chris Math, you'll see that it's got all of this sort of boilerplate code generated for you. Okay, so what I'm going to do now is I'm going to open that up in Visual Studio Code, and we'll take a look at it. So we'll just type in code dot, which will open up VSCode and default it to the folder that we were in there. So let's just make this a little bit bigger. Open up my screen there. So the first thing I want you to see is it's created this Cargo.toml file. So again, if you're used to a JavaScript world, that's equivalent to your package JSON file, right? So it's got this sort of package here. We've got the name of the package, the version, and then any dependencies. So as you start creating your application and it gets complicated and you want to start pulling in dependencies from the outside world, then these dependencies will get listed in your Cargo.toml. Again, very similar to how a package JSON works in NPM. And again, if you want to understand a little bit more about all the the keys that are in your Cargo.toml. It's got a nice little link so you can have a look at that. Other things it's generated is, you see it's generated a gitignore file, so it's going to ignore a /target. So that is the folder that we compile to, and where it generates all our binaries or packages. So, you know, nice little bit of skeleton code for us there. And then of course in the source directory here, you see this main.rs. And main.rs, main is the sort of standard default Rust file that's created, and rs is the Rust extension file. So if we have a look at this, you can kind of see fn main, and I'll explain what that is, but it's basically created a very simple hello world program for me. So println is the equivalent to kind of console.log on JavaScript, or printf in C, and all that's going to do is output hello world to the screen. And fn obviously stands for function, and then you can kind of see that it's code blocks are represented by these curly brackets. And then of course, by default, by convention in Rust, main is your default function name for executing a sort of console application. So that's my application. It's pretty simple. If I want to see that running, I could go onto my machine here, and then I could just type in cargo run. It'll take a few seconds just to build that, and as you can see there, it says hello world, so that works. And if I wanted to, let's say I wanted to check that things worked okay, let's come back to VSCode for a second. So now that you know how to run that, if I wanted to check that my code was syntactically correct, I could just use a command called cargo check. So what I'm going to do is I'm just going to change that println and then put some extra characters in there so it will fail. And then if I do something like cargo check here, I'm going to get an error, which it says cannot find macro print blah 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 lin in this scope. So it's a quick way if I want to just check that my code is correct, and then I can just type in cargo check. Similarly, if I want to build my application but not run it, then I can run cargo build. So if I just remove that, so it's println, let's do this, and we do cargo build. So it's built it, it's not running it, but it's built it. And then if I were to go into this target folder for a second, and then we go into debug here for a second, you can see it's created, you know, all the sort of libraries and the binaries that I need to run my application. So that's what that does. And in fact, if I were to let's just clear that for a second. If I was to remove that target file, let's just get rid of that. So you see it's gone there, and then if I run cargo build again, you'll see that it's going to build that, and then the target folder exists. So that's kind of how that works. And if I go back into Visual Studio Code a second, and then if I mess around with this a little bit, so we're not going to go into all the ins and outs of the language in this video. This is just to get you kind of started. But if I wanted to just maybe put some code in there for a second. So let's do a little bit of variable assignment. So let's say let num equals 25. So this is kind of a immutable value. So it's kind of like const. It's not the same as const, but it's kind of like that. And then if I just put, let's say, well, let's make this my favorite number is, let's put that in here, we'll hit save, and then what should happen is it will say my favorite number is, and this little sort of curly brackets will basically allow us to pass in a variable, so we will put num, and therefore that's going to output my favorite number is 25. So if I come back here, type in cargo run, and you can see it's now outputted my favorite number is 25. Alrighty, so now that we've got a bit of an understanding of Rust and we've created our first program, let's go back to VS Code for a second. So as you can see, there is some basic syntax highlighting going on in VS Code. You see that it's kind of purpled up the FN, and you just got let as a blue there, so that's pretty cool. But it is quite basic, right? So I've changed that let, and it doesn't really know what to do with that. This is not giving me any squiggles or errors like that. So I think we can do a little bit better. So one of the extensions we really want to install is the Rust inbuilt extensions, which is going to give us some of our squiggles and autocompletes that we really want to have. So if I go to the extensions tab for a second, and then I type in Rust, and you will see here there is this Rust programming, Rust for Visual Studio. It's in preview at the moment, but it's actually pretty good. If I just click install, and then that's going to be enabled, and as you kind of see underneath it supports code completion, code formatting, some refactoring snippets, etc. So it's pretty cool stuff. So I'm going to close that out. I'm just going to restart Visual Studio a second. Let's open that back up. And then as you will see, almost straight away, we start to get this sort of nice highlighting occurring. And then if I change something here, I get a squiggle, I expected one of these things. So I start to get this sort of the syntax highlight and code completion that I would want. Alrighty, so what we're going to do now is we're going to get a little bit more advanced. We're going to create a brand new function which is going to add two numbers together. So what I'm going to do here is I'll create my new function. So I'll just type fn as I did before. I'm going to call it add two numbers. We're not going to pass any parameters in there for just now, but I'm just going to create this. And then the first thing I want you to see, again, the syntax highlighting is coming up. I can highlight over and it says function is never used, and you see add two numbers. So it gives me this warning of dead code, and that's one of the advantages of static compilation over dynamic compilation is I get these errors never used. So I'll just change that and we'll put add two numbers here. And then I've got my code completion there. I'm not passing in any parameters. So if I want to return a value from a function, I need to specify the type that is going to be returned, because as I said before, Rust is a static language, so therefore the types have to be known in advance. So it's not like JavaScript where it can kind of the types can change, or I don't need to know them because it's figured out at runtime. I need to specify in advance what they are. So the way we do that in Rust is by using the arrow. So just after these two parentheses here, I just need a little arrow here. And then that is going to specify what my return type is. So in this case, the type is going to be i32. So basically, I'm returning a 32-bit integer. You can put in anything you want there, but that's really what I want. So what we will then do is return a value. So I'm going to return the value 25. And as you see, all my squiggles have gone. Now, if I put a string in there and wrote Fred, you can see it's coming up with this error, mismatched types, right? Which is it's expecting to return a 32-bit integer, but I'm trying to return a string, which is Fred. Now, this is an important thing that I want you to realize. Something interesting about Rust is I don't need to put the word return. I can put the word return if I want, but if I want to return something, then essentially I can have my functions as an expression, which is pretty cool stuff. So therefore, to return a value, then it will take whatever is the last line, the last statement in my function, and that is the value that will get returned, and I can omit return. Now, in that particular case, for it to be an expression, I also don't semicolon terminate that, and that's important. So if I save that here, you're going to see my favorite number is 25, because the last number of our two numbers is 25. We're going to call that. We're going to assign the value 25 to my num, and then that's going to be displayed here. So if I now go to cargo run, and you see my favorite number is 25. Now, if I want to do some sort of calculation there and add two numbers together, then all I need to do is pass in some parameters to do that. So to do that in Rust, all I need to do is put in the name of my parameter, which in this case is n1, and then I need to give it a type. So in this case, it will be i32, and then I want to add two numbers together, so that's going to be n2, and again, I want that to be an i32. So I'm passing in two parameters, which is going to be a number one, n1, and n2, 32-bit integers. And you see the squiggles start to appear already, right? Which is add two numbers is expecting some values. So if I put in 10 and 15, then they that squiggle goes away. But of course, you see now I'm getting unused variable n1 and n2, which is kind of cool. So what I can now do is do n1 plus n2. And then if I save that, actually let's just make that 20 and 15. So if I now run this over here, you're going to see it comes back with 35. Now, if I wanted to, I can return that and just do return, and then it will work as normal. Yeah, so that is Rust. It's a very basic overview. I will do a more detailed view of the language and get into the depths of all the language constructs and how that works, but I just wanted to show you how easy it is to work with the language, and it's a very, very cool language. I really enjoy it, and in future videos I'll show how it works with Node.js and WebAssembly. Now the last thing I want to show you is actually with the extension, how I can then start to debug, etc. within Visual Studio. So let's give an example first of all by trying to run that in Visual Studio and then taking it from there. So if I just go to run start debugging, you're going to see it gives me this error: cannot start debugging because no launch configuration has been provided. And so I say OK, and then it says Cargo.toml has been detected in workspace. Would you like to generate launch configurations? So let's just click yes for that. And then it's going to create all that sort of launch JSON stuff. So we're not going to go into the detail of that, but it's generated for that in my VSCode folder. And that works in the same way as Node.js or C# or any other language. Alrighty, so all I need to do now is just run start debugging, and if I look at my terminal, it says my favorite number is 25. So the nice thing is now, because I've got my launch JSON configured, I don't need to keep switching between my terminal over here, and I can use the integrated terminal in VS Code, and I can just sort of debug things as I go along. And again, I can change the values here, so I can make that to 30, and then if I ran that again, let's just save that and then hit start debugging, you're going to see it comes back with 45, so it's fully integrated. And then of course, if I want to then start putting breakpoints in there, I can do that. I can run start debugging, and then you see it's going to stop at the point that I want. I can hover over N1, you see that value is 30. I can hover over N2, I can see the value is 15, and I can start sort of doing your usual sort of things, start stepping into, etc., and then running that, and then you can see it's now 45, and I can start messing around with everything as before. So getting those Visual Studio Code extensions, I think, is really important and allows you to debug. Anyway, that is the end of this video. Hopefully that's given you an idea of how easy and quick it is to get started with Rust. Hopefully you will start playing around with that yourself, and then in future videos I'm going to start to show you how you can use it with Node.js, how we can use it with WebAssembly, and then we will get into depths of, you know, calling AI, machine learning with it, and then of course we'll get more detailed into the language and how it works underneath. Anyway, I hope this has been useful, and we will speak soon.